This video is brought to you by IXL, used by millions of students worldwide to get ahead in math, English, and more.
Two triangles are congruent if they have the same size and shape. All corresponding pairs of sides have the same length, and all corresponding pairs of angles have the same measure. Here are some common ways to prove that two triangles are congruent. Today, we'll focus on showing that triangles are congruent using these top two theorems, the side-side-side theorem or the side-angle-side theorem. To use the side-side-side or SSS theorem, we'll need to show that all three pairs of corresponding sides of the triangle are congruent. Remember that we show congruent sides using hatch marks. So in these two triangles, these sides are congruent, these sides are congruent, and these sides are congruent. Let's practice with an example. We're given three triangles and need to find two that are congruent. Then we'll write the congruent statement. So we're looking for the two triangles where all three pairs of corresponding sides are congruent. Let's start by looking at triangle BCD. Notice that side BC has one hatch mark, CD has two hatch marks, and DB has three hatch marks. In order for a triangle to be congruent to BCD by the side-side-side theorem, it would have to have these same side lengths indicated by 1, 2, and 3 hatch marks. So we can't pick triangle XYZ because it has sides with 2, 3, and 4 hatch marks. But triangle HIJ has 1, 2, and 3 hatch marks on its sides, so each side is congruent to a corresponding side in triangle BCD. Perfect! Now we know that these triangles are congruent. To write the congruent statement, we need to name each vertex in the correct order. Let's name our first triangle BCD. Now, what do we name the congruent triangle? Well, in our first triangle, vertex B is formed by the side with 1 hatch mark and the side with 3 hatch marks. In our second triangle, the angle formed by the sides with 1 and 3 hatch marks is angle J. So we'll put angle J as the first vertex in our second triangle name. Great! Now what? Well, BC is the first side listed in our first triangle name, and it has 1 hatch mark. So we want the side with 1 hatch mark to be the first side in our second triangle name. That's side JH, so H will be the second letter in our triangle name. Now, we only have one vertex left, so we'll put I as the last letter in our triangle name. This makes sense since sides CD and HI both have 2 hatch marks. Great! So the congruent statement is triangle BCD is congruent to triangle JHI. Let's move on to the side-angle-side theorem. To use the side-angle-side theorem, we need to show that two pairs of corresponding sides are congruent and the angles between them are congruent. To use this theorem, it's important that the congruent sides and angle are in the same order that we read in the theorem. Side, then the angle in between, then another side. Remember that we show two angles are congruent by marking them with the same number of arcs. Let's check out an example of proving congruency using the side-angle-side theorem. We'll find which two triangles are congruent and then write the congruent statement. We're looking for two pairs of congruent sides with a congruent angle between them. Triangle QRS and triangle LMN have two congruent sides and a congruent angle. But notice how on triangle QRS, it's not the angle between the sides that's congruent to the angle in triangle LMN. So we can't use the side-angle-side theorem on triangle QRS at all. Let's compare triangle LMN and EFG. They have two pairs of congruent sides, and the angle between these sides is also congruent. So these triangles are congruent by the side-angle-side theorem. Great! We'll complete the congruent statement in the same way we did in the last example, and make sure that corresponding sides and angles are listed in the same order in each name. Let's name our first triangle MNL. Then our second triangle name should start with GE, since both MN and GE have 2 hatch marks. Notice we want to name this side GE, not EG, because angle E and angle N are congruent, so those both need to be second in our triangle names. Then we'll complete our congruent statement with vertex F. So we have that triangle MNL is congruent to triangle GEF by the side-angle-side theorem. Great work today! We've learned how the side-side-side and side-angle-side triangle congruency theorems work. Now try some examples on your own.
Head over to IXL.com for more practice on this skill and thousands more videos in math and language arts.